Hi, hello everyone. Dante here. Hopefully if you're watching this video, your environment's already set up. If not, I've got another video for that already. Also, if you're watching this video, I'm going to assume that you have a basic understanding of templates because we covered templates in the previous video. So I'm going to get right into this video, which covers rule of 5. So the rule of 5 effectively has to do with the destructor, the copy assignment operator, the copy constructor. That you already know is the rule of 3. We'll briefly review it, but then we're going to cover more information to do with move and move semantics. So move is, in short, a way to copy fast, and let's talk about how it works. So what I'm going to do is I'm going to probably install Microsoft Whiteboard here so that I can sketch some things out so that you get the concept, and then we'll jump into the code. I can't use Whiteboard without signing in, huh? Okay, scratch that. We're going to do this in Paint. So what we want to do is we want to discuss the difference between copy and move. So let's start by kind of dividing our screen in two. And we'll do the copies on the left and the moves on the right. Forgive me for my handwriting. Okay. So starting on the left here with copy, we're going to think of our vectors as big boxes of stuff. So let's say I have a vector here that has a lot of elements. So maybe it stores a 0, and then it stores a whole lot of stuff in the middle. And then at the end, maybe it stores something like, I don't know, 1,000. So we've got a lot of elements here, and this is in a vector that we'll call A. Now we want to create another vector, B, and we want it to be that A equals B is true. So we want them to be a copy of each other. So in this case, what we need to do is we need to copy A into B. So a way to do this in our code is whenever we create B, if we've not created it yet, we say, vector of whatever type, B, and then we do the parentheses for the constructor. We could also do curly braces, and we put A in. This invokes the copy constructor. So the copy constructor is one of the rule of 3 that you wrote last semester. And the way copy constructor works is it duplicates all of the data. So a simple way of doing this is if we think about our vectors now, instead of as boxes of elements, as a class, what do they have? Well, A has the following information. It has a pointer, which we're going to say is PTR. It has a size, and it has a capacity. So the size and capacity are just numbers, and they're stored very near A. So the size, let's say, is 1,000. Let's say the capacity is even more. Let's say the capacity is like 2,000. So we've got some elements floating off here in the void that aren't really part of the vector, but they are stored in memory. Capacity refers to how much space is physically taken up by PTR. Size refers to how much of that space we are using to store values that we care about. So what we want to do now is we want PTR to be somewhere. Well, PTR is not stored here. Here is stored a memory address. Memory addresses we start by writing OX, and then we write the location in memory of the first element, of the 0. So maybe that location is something like FF7 something or other, right? This is a bit of a weird number that you may not have seen. It's called a hexadecimal number. It's basically using mathematical base 16. So a really simple way that we could kind of copy this, and what C++ will do by default, is it'll just copy whatever's in each of these boxes right here into B. So it'll say the value here is going to be 0xFF7. It'll say the values down here are going to be 1,000 and 2,000 respectively. Well, these values being what they are, that's good because we want the size and capacity to be the same between them. So I'm happy with this. but the value up here I'm less happy with. Let's talk about why. So I'm going to erase the little dividing line that I put in because we're not going to talk about move just quite yet. The reason this is a problem is that both of them are referring to the same elements in memory. So let's draw a little example of what that means. The memory address 0xFF7 is basically somewhere in your long line of memory. So this is your computer memory, and it's one long line. And let's say 0xFF7 is here. It's this little bucket. Well, all of the buckets that go down for the next 2,000 buckets, according to the capacity, are also part of this pointer, and they're all here. And the problem now is that A and B, both of their PTR goes to the same elements in memory. So what that means is if I compare them, they are equal. So we kind of accomplished our goal of AB being true. But the problem now is if I say A at position 0 actually equals 1, that would cross out the 0 here and it would make it 1. The problem is B doesn't have its own values. B and A share the same values. So B at position 0 is also now 1, even though we would expect if they were copied that B at position 0 would still be 0. So because this is not happening, this is what we refer to as a shallow copy, where the full values are in our vector were not copied over. We just kind of shallowly made two vectors that really go to the same place. And that's not what we want, almost ever. So what we need to do is we need to write a copy constructor so that we can guarantee a deep copy. So for the copy constructor, what we need to do is we need to duplicate all of these 2,000 values, which is going to be slow and painful, but we do it anyway. So we duplicate each of the 2,000 values with a for loop over here, and that's how B has its own memory over here, and that's why it's a copy. And now if we do this, this works as intended. A0 equals 1 becomes 1, but B0 remains 0, because they're not going to be the same memory address. The memory address is different. So maybe B points to something like 0x, D80 or something like that, which is just a further down place in memory, quite a lot further down. And this is the copy. So it's not moved yet. Now, let's talk about the difference between copy construction, which is this, and the copy assignment operator, which we could get by saying B equals A. Remember, a single equal sign is not comparison, it's assignment. So we're now assigning the values from A into B. So this is actually super similar to the copy constructor. We want to do a similar thing where we copy size and capacity over, and we copy all of the values individually. But if B is on the left-hand side of an equal sign, we assume that B already exists. It already has some values in it. So what does that mean? Well, that means that B's values have to be cleaned up. If we forget to clean them up, let's say B's values live up here. If we forget to clean them up, well, the values are going to stay here. So this is what's called a memory leak. So how do we clean them up? Well, we actually do effectively what the Destructor does. Now, we can't call the Destructor. We can't manually invoke it because doing so is really dangerous and a bad idea. So instead of manually invoking the Destructor, we will instead clear up the memory ourselves. Finally, that's copy assignment operator, so that's the only difference. It first clears up the memory in B because we need to delete whatever was already in B, and then it performs the same steps as a copy constructor. We discussed Destructor briefly there. Effectively, it just cleans up memory to make sure that we don't have memory leaks. The final thing we can talk about now is going to be move. So let me clear the screen, and we'll talk about move. So move effectively works in the following way. A has data, a lot like before, 1.1000. And B wants that data. We want to move the data from A to B. So A after the move should have no data anymore. the reason this is useful is, let's say, for instance, that we're in a function. So let's say I'm in a function here that has a vector as its return type. So vector, and the function's called foo. Foo's just the name for a made-up function. So returns a vector. Well, the problem is, if I finish the function and the vector is really big, let's say I try and return a, which is that really big vector. Well, after the function's over, we need to delete a because the memory should not be there anymore. And let's say that we want to do this. B is equal to foo. Well, now we're assigning B to A, but what happens is A kind of needs to get destroyed. So think about it this way. It would be really slow if we copied all of the elements over, copied all the elements over into B, and then we destroyed all of the elements. That would be extremely slow. So instead, in computer science, we have a smarter solution. So let's draw our little object tables again. So we have here A, and we're going to have a table over here for B. So A has PTR, which is some value. Then it has size. I'm just going to write SZ, and then it has capacity. I'm going to write CP. B has, if it's move constructor, no values because we're constructing B. But if it's assignment operator, this would be a move assignment operator because we're doing an equal sign. It already has some values. A lot like with the copy assignment operator, we want to delete B's values first because otherwise we will leak them into memory. But once that's done, what we want to do is, since the values in A already exist and they're already good, and we just want A to be empty afterwards, what we can do is we can actually just put PTR in here directly, just like how we did the shallow copy earlier. We'll copy the size over and copy the capacity over. But then the trick is, for A, we set pointer to no longer, we copied it over earlier, but now what we do is we set it to no longer point to the array, because B now is able to access the array. It's able to access this data. A should not be able to access the data. So what do we do with A? We set its pointer equal to null. And we set its size equal to 0 and capacity equal to 0. So what happens now is B points at this memory and A points it up at null instead of at the memory that it used to own. So the memory's been moved from A to B, and we didn't have to copy the values, we didn't have to delete the values, we didn't have to do anything. So this is super efficient. And it turns out that's actually what C++ does by default. Whenever you return a value from a function, particularly a large value, it tries to move the value. So having a move assignment operator and a move constructor is pretty good. That said, what if we want to move values on our own? Let's say we just have A and B together, and we want to do B is constructed from A, and we want to do it via move. We can say B is constructed from std : move of A. What this does is this actually just converts A into a value that tells C++ to invoke the move constructor. Move on its own does nothing to A. It does not edit the values at all. But it lets our code know that we need to invoke the move constructor in this case, or move assignment operator if we used an equal sign. Okay, so that's the concept. Let's take a look at it in code. So from the last assignment, we kind of created a little templated A class here. I'll just keep working with the same class. So we need to write a destructor for A. Generally, if you need to write a destructor, it means you have pointer memory here. So let's just change tObject to tObjectPointer. And now object is going to be a new tObject, which is constructed from that object, just like so. So now it's a pointer. Because it's a pointer and we use the word new, every time you use new, you have to pair it with a delete somewhere. So since we did a new in the constructor, let's do a delete in the destructor. So we'll delete object. Now you'll notice I said new t and then I used parentheses. In that case, I just do a delete. But if I said new t brackets, this means I'm creating an array of type t, and I put however many elements I want in here. If I use new with brackets, I also then have to put brackets on my delete. I just put them right here. That said, for this case, I don't do that because I did not use brackets. So this is a destructor. It's very simple. Let's now talk for a copy constructor. So how would a copy constructor look? Well, a copy constructor takes const a reference, just like this. So we have passed in another a, we'll call it other. And what we want to have happen is we want to have the a that we refer to by the name this equal to the a that we refer to by the name other. So the way to do that is to say object, that's referring to this object, the one belonging to this a. We want it to be a new t constructed from other arrow, because other is, sorry, other's a object. So other dot object. But this is a pointer. So what we need to do is we need to dereference that pointer. So what happens here is we do other dot object and it fetches the pointer belonging to other. We now dereference it. So what that does is that gets the actual value that's there and it copies the value in whenever we create our pointer for object. So this is our copy constructor. Now let's write the copy assignment operator. You're familiar with copy assignment because you did it in 121, but here's a brief refresher. Your copy assignment returns a reference to the current object. So a reference, operator equals, that's how you say assignment operator. And since we want to do copy, we do it the same as we did the copy constructor. So same name in here and everything. Now, since this is the copy assignment operator, it's not a constructor. We have to do things manually. So the first thing I said was with an assignment operator, you have to delete whatever is in this. Well, whatever's in this is object. So we could do delete object. If we want to be a little more clear, we could say delete this object. But it gets to the same place at the end. So this is doing effectively what the destructor does. We almost effectively copy the destructor. And then what we need to do is we need to mimic what the constructor does. So what the constructor is doing there is it's saying that object is equal to a new t of dereferenced other dot object. So this is the same line as what we did here, but this is using list initialization syntax, and this is using regular C++ syntax. Again, you could write your constructor in this way, and then not have the list initializer. But in C++, we use list initializers by default because they can convey certain advantages with regard to speed. This is almost a complete copy assignment operator, but we now have an interesting case. Let's say I'm in main and I have an A and a B. And then I say A equals A, or I say B equals B. We're now assigning other to yourself. So if we delete object, the memory is deleted. So then we try and do new on dereferencing deleted memory. This memory just got deleted because A is equal to A. So delete object, deleted other object, because they're the same. Object and other object are the same if A is equal to A. So if we deleted it and then we try to access it, this is an issue called use after free. And it's a pretty big problem. So what we want to do to avoid that issue is we want to say if this is equal to the memory address, this is the address of symbol, memory address of other, then what we need to do is instead of trying to do any of this, we want to just stop right away. Well, what are we supposed to do to stop? We're supposed to return this. So let's do it. Return this. Now there's one problem. This is a pointer, and we're supposed to return a reference. So we need to return the dereferenced form of this. And we need to do that at the end of this function too. So if it's a self-assignment, if it's A equals A, nothing happens. That's what this line says. If it's not self-assignment, delete the left-hand side and then copy the value from the right-hand side and then return the left-hand side. This is just convention. That's why we do this. So that was copy and destructor. So we've got the rule of 3. Let's now finish up with the rule of 5. So for the rule of 5, what we do is we'll do a move constructor. So the move constructor is a double ampersand other. So this double ampersand is involved in move semantics. It was also added in C++ 11, and it can be read as right-handed reference. So a right-handed reference to other. You could also call it a remove reference. And it's purely used for move. So what I want to do if I'm trying to move the contents of other into A is I can actually just say the object for A becomes other object. So now what I've done is I've simply copied the memory address over. So if we go back to here, that copies PTR into B here, which is good. But now what we need to do is we need to make sure that A points to null. So now we say other object is equal to null, if you're more of a Microsoft C++ guy, or standard null pointer. I think actually you can just say null pointer if you're more of a language standard kind of guy. And there you go. So that's the move constructor. It's really quite simple. Now we've got to do the move assignment operator. So we say operator equals, and because it's the move assignment operator, we mimic what we did for the move constructor. So we just go and we can copy this. So what we want to do is we want to say the same things that we do in the copy. We want to do first the check for self-assignment, make sure that nothing happens. Now we want to do what we did up here. We want to delete ourselves if we're not going to do a self-assignment. And now we want to mimic the move constructor. So we want object to be equal to other.object. And then we want other.object to be equal to null pointer. And remember, at the end, by convention, we have to return star this. And there you go. That's your move assignment operator. You'll notice I mostly borrowed from the copy constructor, which borrowed this part from the destructor. And I also borrowed from the move constructor. So in general, the trick for any operator, if we have a constructor, so one, we have to have destructor. That's the first one. Then we have to have corresponding constructor. So that would be copy or move, depending on the situation. Once we have that, what we do is we do build assignment operator by the following. So step one, what we need to do is we need to do check for self assignment. So that's what that if line does. Step two, what do we need to do? If it's an assignment operator, we need to basically copy paste destructor. All right, step three, we now rewrite corresponding constructor without list initializer. And finally, return this. And that's it. That's the way to build assignment operators once you've made the constructors. So the only tricky part now for you is coming up with the constructors. And the vector assignment constructors aren't too complicated, but you may need a for loop. Bit of a hint there. At least for the copy. For the move, you will not. But yes. There you go. That is a bit of an introduction to the rule of 5, kind of working it out and drawing it out step by step. You get to see it in some syntax. I will try and post this code in a GitHub repository linked in the description, so you can take a look at it. But the code was in the video, and I think it's fairly short, so I will maybe not have that up by the time the video is posted. But there you go. Thank you so much for watching. Hopefully you're a little more clear now on rule of 5 and move semantics. Move semantics referring to the move assignment operator and move constructor, as well as how to invoke them. So for instance, we said we do that with standard moves. Now we could say something like my A is equal to move of my A. And this would, of course, be a self-assignment, which wouldn't do anything in our code. But yeah, so this is how one would invoke move. So really, it'd be best if we had like a my B, but we don't. So anyway, there you go. Thank you again for watching, and I guess I'll see you next time I have to make a video.